Okay, so I need us to look at the rules for balancing equations at the top of our notes and be sure that we're following the directions the way that it says. So the first thing we do after copying down the equation correctly, we obviously don't need to do that because there's plenty of room on our notes. But the next thing we do is count the number of atoms of each element on each side of the equation. So it's already listed out for you, but for me I need to write this out. So I've got sodium and chlorine on both sides that I'm going to have to count. And we count it twice, once for the beginning and another time for the end. So everything to the left of the arrow is what we want to count for the reactants. So we need to ask ourselves, how many sodiums are there? Well, right now there are no coefficients and no subscripts, so that means there's only one. And when we look at chlorine, we have 2 as our subscript here, no coefficients, so that tells us there are 2 total. Then over here on the right, we've got our products. Okay, we have NaCl. Again, no subscripts or coefficients for either, so that means we have 1 of each. So right now, looking from left to right, we have 1 sodium and 2 chlorines on the left, and 1 sodium and 1 chlorine on the right. So as it stands right now, it appears that 1 chlorine has just disappeared into thin air. And we know that's not possible because the law of conservation of mass tells us that all the matter is going to stay there somewhere. It's just going to be shifted around a little bit, but we can't lose matter and we can't gain matter out of nowhere. So this is where we're going to go ahead and use these spaces in front of the formulas to add coefficients. So whatever coefficient we add to the front is going to multiply all of our numbers by that coefficient. So right now, I need to decide where I'm going to put this coefficient. The only place it really makes sense, because our sodiums are the same, our chlorines are different, I need to multiply this side by 2 in order to make myself have as many chlorines as I did at the beginning. But the thing is, this multiplies everything behind it. So I'm going to have to change my numbers. This now multiplies my sodium by 2, and it also multiplies my chlorine by 2. Now I have 2 of each. So when I review my numbers, right now I've got 2 chlorines on each side, which is fine, but now my sodium count is off. So I need to go back to the beginning and just add a coefficient in front. And this multiplies it by 2. So right now I want to make sure everything's accounted for. It's kind of like if we go on a field trip, I want to be sure I've got the same amount of students at the beginning of the day as I do at the end of the day, right? Like I don't want to pick up a random kid. I also don't want to lose any of you, even though some of you might not think that. So we want to be sure we have the same amount. So right now this equation is balanced. You're going to leave this space blank right here because we don't need to add any coefficients. Our 2 is the subscript and that's just fine. So let's move on to the next one. I've got hydrogen and oxygen. When those come together we make water. So we need to list out our elements that we've got to count. I'll go ahead and count them up. So this 2 tells me I've got 2 hydrogens. This 2 tells me I have 2 oxygens. And now on the product side, this 2 tells me I have 2 hydrogens. No subscript tells me I've only got 1 oxygen. So when we review our numbers, I've got all the hydrogens I'm supposed to have. I left with 2 and I came back with 2. But I've got 2 oxygens at the beginning of the day. I'm only coming back with 1. That's not good. That means I've lost 1. So what we need to do is add a coefficient to the front of water to make us have as many oxygens as we're supposed to. Okay? I need to multiply 1 by 2 in order to get 2 over here. But this is going to mess up my hydrogen count. It's okay because we can go back and fix it on the other side. So when I multiply the coefficient by the subscript, 2 times 2 is 4. And I'm going to multiply 2 by my oxygens, and that gives me 2. So I fixed my oxygen count. When I look at my hydrogens, I had 2 at the beginning, now I have 4 at the end. Well, 2 goes into 4 2 times, so I can add this as a coefficient and fix my problem, and now it's balanced. Now let's do this other one. I've got lithium and oxygen yields lithium oxide. Alright, so lithium, there's only 1 at the beginning and 2 oxygens. And at the end I've got 2 lithiums and 1 oxygen. Now on these other 2 problems, we've only had one of the counts be off, and this time both of them are off. So somebody told me once that it's always easiest to start out with a diatomic molecule because they come in twos. And so if that number is off, go ahead and fix that, and then everything else tends to fall into place. And so we're going to include hydrogen on that too. So this means we're going to start with oxygen. Oxygen has 2 at the beginning and only 1 at the end, so we need to add a coefficient at the front. When I have 2 as my coefficient, that means I'm multiplying that by my 2 for the subscript of lithium, which gives me 4, and I have 2 oxygens. So now my oxygens are all set, but now my lithiums are even worse than they were before. I've got 1 on this side and 4 on this side. So you need to ask yourself, what do I multiply this lithium by to end up with 4 like on the right hand side? Well, since it has no subscripts, this should be really easy. You just put that exact coefficient that you need and recount just to double check that everything is right, and it is. Okay, now we've got aluminum chloride, and it breaks down into aluminum and chlorine on its own. So on the reactant side, I've got 1 aluminum and 3 chlorines, and on the product side, I have 1 aluminum and 2 chlorines. So aluminum's fine, chlorine is not, and this is where it gets kind of interesting, because these other ones, I've had numbers that kind of go into each other, but this is not the case. 3 doesn't go into 2, 2 doesn't go into 3, so now we have to enlist some of our math ideas about the least common multiple. So that means we need to think about a number that both 3 and 2 go into, but we need to think of like the smallest possible number there is. Okay, so if you think about it, think back to like elementary school, and hopefully you remember that 6 is the least common multiple of 3 and of 2. So our goal here is to have 6 chlorines on both sides, and you need to ask yourself, all right, how am I going to get 6 chlorines on my reactant side and my product side? What number can I put as my coefficient? Well, since chlorine is on its own on the product side, let's go ahead and start with that one. So ask yourself, what times 2 is 6? Hopefully you know that it's 3. So we'll recount to show how many there are total. Okay, and now on the other side, on my reactant side, I need to think, what times 3 is 6? And that is 2. So when I do that, I recount that, but I cannot forget about aluminum because it's attached. Now my aluminum is being multiplied by 2. So my chlorines are fixed, aluminum is not. Aluminum is now off. I've got twice as many at the beginning as I do at the end. So all I need to do to fix it is put a coefficient here where aluminum is by itself and recount to show that it now matches up. So this next couple are a little bit more involved because we have several elements to deal with. So give me a second so I can write these all out. And I know it's a little messy. It's because I'm writing with my finger on my iPad, so I apologize. So let's count out everything on the reactant side. I've got 1 magnesium. I need to make sure I carry this 2 to the inside of the parentheses. That's something we saw last week, and some people weren't sure what to do with it. I've got 2 hydrogens here, and I also have 1 hydrogen here, so I've got a total of 3 because I have this addition sign here. Finally, I have 1 chlorine, and on my product side, I have 1 magnesium, 1 oxygen, 2 hydrogens, and 2 chlorines. Alright, so again, at the very beginning, we need to kind of look at what we've got, see what's balanced and what's not, and here we really have a mess because the only thing that's already balanced is magnesium. And one thing we need to keep in mind is we want to look for O's and H's. If we have those, we'll start with them. The oxygen is the easiest one to deal with because 1 goes into 2 really easily. 2 and 3 don't really work together very well. That's when we deal with the least common multiple. So we're going to start with oxygen, and I've got twice as many oxygens at the beginning as I do at the end. So I want to add a 2 here for my coefficient. When I do that, that messes up my hydrogen number. So I need to change that to a 4 because 2 times 2 is 4, and I also have 2 oxygens now. So that's fixed my oxygen problem, but it still hasn't quite helped me with my hydrogen issue. Cool thing over here is that hydrogen and chlorine are together, so whatever I do to this is actually probably going to fix my issue. So I know that I need 2 chlorines on the left because I have 2 on the right, so I'm going to put a 2 as my coefficient and fix my chlorine number. This also fixes H because I have 2 here plus 2 here now. 2 plus 2 is 4. And when you look at these numbers, it all matches up. Finally, I've got the photosynthesis equation here. Carbon dioxide and water yielding glucose and oxygen. So we'll count everything out at the beginning. I've got 1 carbon. I have 3 oxygens because I have 2 here and 1 here. And then I have 2 hydrogens. And on my product side, I have 6 carbons. I have 8 oxygens because I have 6 here plus 2 here. And then I have 12 hydrogens. So nothing's right. We're going to start with oxygen and hydrogen. The easiest one to deal with is hydrogen because 2 goes into 12. 3 does not go into 8. So what I can do here is put a coefficient of 6 in front of the water. I can multiply 6 by 2 to get 12. And then I need to change up my oxygen count. I've got 6 oxygens plus the 2 that I have over here with carbon dioxide. And that gives me 8 total. So when you look back and forth at the numbers, you're like, oh yay, we're done. But we're not. We still have to deal with carbon. I've got 6 carbons as my products, and that means I need 6 as my reactants. I need to put a 6 there as my coefficient and recount. But now I also have to recount my oxygens. This gives me 12 plus the 6 here. 12 plus 6 is 18, so I'll change that. And now the nice thing is that oxygen is by itself over here, so whatever I do is going to be like the icing on the cake. I need to remember that I have 6 here, and they're untouched. So I need 18. I have 6 already that I'm not going to do anything with. So 18 minus 6 is 12. Then I need to make sure that whatever I put in front of this O is going to be multiplied by 2. So think to yourself, what is multiplied by 2 to get 12? And you should put 6 there. Now I'm going to say this one is one of the most challenging ones, so if you're a little bit confused, please make sure you write down your questions on your notes and come back to class and let me know about them. But again, we're going to take some baby steps in class and do a lot of practice with this over the next few days. So if you're not quite comfortable with it, I promise you're going to be comfortable with it by the end. So again, make sure you bring your questions to class, and I'll see you then.